Welcome to your future. Welcome to Vision Academy. Let us unlock your full potential.
Welcome to Vision Academy. When we look at a list of numbers on a page, they can seem highly abstract, but every mathematical sequence is a hidden picture waiting to be drawn. Let's start with the absolute simplest sequence, a repeating line of ones. Look at the split screen. On the left, we have the numbers. On the right, we map each one to a single apple. One apple, one apple, one apple. Now look at standard counting numbers. 1, 2, 3, 4. To draw this, we map each number to a growing group of objects. One ball, then two balls side by side, then three, then four. The visual footprint expands exactly as the numbers increase. We can also draw odd and even sequences. Odd numbers are 1, 3, 5. Even numbers start at 2. 2, 4, 6. To build either of these, we use a specific rule. We add 2. We jump from 1 to 3 by skipping one number in between, adding exactly 2 items to our visual group every single time. Drawing linear groups and tracking skip counting rules gives us a solid foundation. By knowing how to map numbers to physical objects, we can use that exact same logic to build much larger, complex geometric shapes. This brings us to triangular numbers. If you look at the sequence 1, 3, 6, 10, the pattern might not be obvious. How exactly does a list of flat numbers physically build a triangle? We start with the base of the sequence, the number 1. This is represented here on screen by a single circular ball. To find the next number, we apply a stacking rule. We place a new row of 2 balls directly underneath that first one. Count them up, and we have 3. By connecting the outer edges, we see a clear triangle. The rule continues by adding exactly one more item to the bottom row each time. Add a row of 3 balls, and our total becomes 6. Add a row of 4, we get 10. Add 5, and we hit 15. The geometry expands perfectly. A triangular number is simply the total count of objects within one of these stacked grids. We can physically see the shape of the numbers. Next, we have square numbers. While triangles grow by expanding their bottom row, squares demand absolute symmetry. To build a square, the length and the width must be perfectly equal. Look at this equation, 2 multiplied by 2. To draw this out, we arrange 2 rows and 2 columns of objects. Count them, and the total sequence number is 4. The equal sides naturally form a square. We apply the same logic to 3 multiplied by 3. We lay out 3 rows and 3 columns of blocks. This arrangement gives us 9 total blocks, locked inside a symmetrical boundary. Let's test this out. Grab your notebook and try drawing the layout for a 5 by 5 square number. Count up the objects and see what total value you get. Pause the video here to figure it out. Let's check your work. To build it, you need 5 rows of 5. When we lay out that grid and count every star, the sequence number is 25. Anytime you build a sequence by multiplying a number by its exact self, you automatically construct a symmetrical 2-dimensional square. We've drawn in 1 dimension, and we've built shapes in 2 dimensions. Now we step into the 3rd dimension with cube numbers. A common trap is taking a flat 2 by 2 block arrangement and calling it a cube. This is actually a cuboid or a brick. It has length and width, but it's completely flat. To make a true mathematical cube, we have to add depth. A 2 by 2 square needs to be exactly 2 blocks deep. When we stack those extra 4 blocks behind the first layer, we reach a total of 8. 8 is our first true cube number after 1. Scaling this up, a 3 by 3 by 3 cube is 3 blocks high, 3 wide, and 3 deep. When we fill in all those layers, it requires exactly 27 individual blocks. To build a 4 by 4 by 4 structure, we need 64 individual blocks to complete this solid 3-dimensional shape. Let's review the visual roles we covered today. Here is a summary chart showing linear groupings for odds and evens, 2-dimensional triangles and squares, and 3-dimensional cubes. Take a screenshot of this right now to use for your exam prep. Numbers are the actual blueprints for physical geometry. Once you know how to draw them, you can map out any sequence. If you found this visual breakdown helpful, hit the like button and subscribe to Vision Academy for more step-by-step guides. See you next time.
Like this video? Subscribe to our channel. Share this video. Thank you. Shukriya.